just before we launch into it, what is the distributive law? I'll show you. I'll write it out for you. That's right. Okay, so this is the easiest way to demonstrate the distributive law for you. A, B, and C, they're just any numbers. Okay, so I'm calling on your understanding of algebra so that, like if I give you an actual example, that's true for that. But this is true for any numbers. So when you see those brackets there, right, you see two things. Number one, there's actually a multiplication sign hiding in there, right? So A outside of the brackets is short for A times what's in the brackets. Okay? Now here's where the distribution of the distributive law comes from, right? That multiplication is distributed among all the things inside the brackets, right? Just like, okay, I've got pieces of paper, exam notifications, and I distribute them to everyone in the class, right? There's the class, and I give one to each of the people in there. It just happens to be a small class, okay? So, let's have a look at, I'm going to give you 3 problems that are very easy to do when you use the distributive law. Okay, so let's do this, let's do this, and let's do this. Okay, watch how I take advantage of the distributive law, okay? Some of you might know what double of 47 is right away, but if you don't see it straight away, you can use the distributive law to help you, right? Watch. 47, right? 47. We have a place value system. That means that depending on your place in the numbers mean different things. The digits mean different things. As opposed to, say, the Roman numeral system, which it doesn't matter where all those ones are. All the ones are the same. They all mean 1, and so that's 3. But this 4 and 7, they mean different things, right? The 4 doesn't mean 4. What does it really mean? Yeah.
Can we turn tens?
Yeah, we can. Adam, yeah. That's exactly right. This is the units and this is the tens, right? So really, it's 40 plus 7. Can you see that? That's what 47 means, okay? Now that is being multiplied by 2. And by breaking it apart, I make it easier to multiply. What's double of 40? It's 80. What's double of 7? 14. That's simple. 94. Very good. Okay. All right. Let's move on to the next one. A half times 192. Now, I don't know about you, but 192 is a bit awkward in my head. You can break this up in whatever way you like that makes it easiest. Personally, I'm going to break it up like this. I could break it up into all of its parts. Into 100 and 80, and 90 and 2. That would be fine. But I don't need to because 180 is really easy to take half of. And 12 is really easy to take half of. What's half of 180? What's half of 18? Because 18 is a small number.
9.
It's 9, right? So if I stick a 0 on the end, I just stick a 0 on the end of that.
96.
And half of 12 is 6. Done. Okay. Shh. All right, one last use of the distributive law. This looks really gross, right? For sure you'd reach for a calculator with this, but you don't have to. Watch. I could break apart the 17, but I'm going to be a little bit sneaky, and I notice that 9 is very close to 10. I'm going to write 9 as 10 minus 1, because it is 10 minus 1, right? And that makes it so simple. Multiplying by 10 is easy. It's 170. You just whack a 0 in there. And multiplying by 1, well, I hope we can multiply by 1. Okay? So 170 minus 17, it's still not super straightforward, but it's certainly much easier than thinking, the 9 times 7 is going to be 63, capital, blah, blah, blah. That's just going to be, 153.